for printing figurines, what you should do is replace your knob with something like this, more useful to do, not like the thing with the hole. Or this thing I'm gonna put this now, these hinges. I'm gonna put it here for an acrylic door, or some connectors for here, or making an acrylic cover, or something like this. I mean, don't show anyone any figurine. Never. Well, okay, in about a week, and this I will write it later in River. In about a week, I'm going to join you there. So what I want you to do now is, let me check the schedule. I want you to do to complete the self-assessment until archive. I want you to complete the self-assessment until at least machine design. By today, okay?
Problem is the motors we have, the shaft it has, it's very slippery. It doesn't have any feature on which the coupling can really manage to stick to. It's really hard. So that's what we were figuring out yesterday. There was not.
Okay, I mean the machine, all of this, I mean even the Fabacademy itself, it's not about success. Okay, if they wanted you to success, they will tell you to do some other thing that they make sure you are succeeding.
Yeah.
This is about learning. So what you have to do is you show your failure, and you tell them what you learned about that.
Right. Yeah. I guess that's the
And
way.
what would you do for making this work?
Yeah. So all the
and
mechanics.
the machine presentation is not about presenting a successful machine. It's only about presenting.
Yeah, but since I thought I'll give it like some other things, small things which I want to try, I just wanted to give it a go. So maybe, yeah, that's why I just postponed it, or else the complete.
But anyway, the next week is the absolute
Right.
no more. You have to present.
Yeah.
Whatever you have.
Yeah. Yeah.
I mean, when I see like some other projects that say, "Oh," and Neil says, "Oh, it looks like you didn't have any problem." I mean, this is fake. This is that only one person did the machine, and the rest were looking. Because if you split the machine in a team, the most probable thing that is going to happen is the machine is not going to work. But those teams that they appear like they make a super machine, everything was working, that means that one or two persons there were doing the machine and the rest were just looking. Oh.
Yeah.
Because this is what happens when this is the team. The team thing is like this. Theoretically, it should be quicker, but practically it's not. I mean, you are a mechanical engineer, isn't it?
Yeah.
Maybe you could do the machine quicker than in the blue. Maybe. Well, let me share screen. Um, so, what do you have here now? Do you have foam, machinable foam, like high density foam, or not? Hello?
You hear us? Hello.
Oh, now.
Yeah,
Do
yeah.
you have?
No, we don't have the foam, high density foam.
Hmm. Well, unit for the assignment today can be done very quickly, depending if you have the materials. So what we need is not much than this. Is a piece of foam from construction that is something like, I think, yeah, because I think the shopbot has a maximum of 15. Can someone measure quickly this distance between the end of the mill and the base? Can someone measure this distance now? Quickly? I think it's 15. But because you have the sacrificial layer, maybe it's less than that.
Yeah, it's about 15.
About 15, okay. So you need, sorry? Sorry? Did you say something? Okay, you can have or one piece like a 12, something like this, height foam, or you can glue together 3 of the construction insulation foam. No, the construction insulation foam is something that, seen from the top, has a shape like this. I don't know if you have this. It's a plank like this, very, very long, like 2 meters 44 long. And the planks go one after the other like this. This is construction insulation foam. And it's high density, which is the important part. So what do you do for insulation there? Do you have insulation in construction? Do you put insulation, or you never put insulation?
No, no, we don't know what insulation, what construction.
I mean, in cold countries, but maybe you don't have this. We put this insulation foam. This is the exterior. These are the bricks. okay, of the house. I'm looking from the top, and then you put this insulation here, and then you leave like air, and then you put like the internal wall, thin internal wall. This is the construction, the basic construction of a wall. It's the exterior hard brick, insulation, air, and interior wall, and here maybe plaster. And this is like 30 centimeters. It's not only for cold countries, because in hot countries, if you have air conditioning, like the loss of cold to the exterior is very high, and cooling is 3 times more expensive than heating. So you also put insulation. But maybe you put another kind of insulation. You have never seen this? Like in works over there?
We haven't got much chance to, see all this and how they're built and all.
Oh, let me check.
The insulation, how they do. Yeah, for the walls. Huh?
Or you do this one. There is another kind that you project this.
Yeah, this is polyurethane, right? Foam.
This is foam or
Spray.
glass wool?
Sorry?
Is it foam or glass wool?
This is foam, I think. Polyurethane.
The foam. This is foam.
Okay.
I have.
But in the past, we used to do this, spraying foam, and now we use it like this, in blocks, like this. Have you seen this? Maybe in another color? In construction places?
I've seen this. I've also bought it, but we don't have it right now over here.
Yeah, but I mean, can you obtain this thing?
I should be able to obtain.
In construction departments.
Yeah, in construction department store. Like with one plank of this, you have for a lot of students.
Yeah. So this is a polyurethane foam, right? It will be hard and then it can powder very easily.
Yes.
Okay.
So if you get this, I don't know what is the height of this. But what you do is you pile up enough to be around 12, like not more than 15. Remember, no more than the height that you have freely available. So you pile it 2 or 3, whatever, depending on the measure of this. So it never goes over here, and you glue it like, with something, like maybe, I don't know, double-side tape, something like this. Okay, and what you have to do is this: you cut this in 30 by 30 centimeters, and you give each one to a student. And this is the base that you have for making the mold now. So let's imagine that you already have this part, foam. Okay. So now, as Neil said, you have 2 options. You mill your mold here. Say you want to do something like this. This is the original volume. One option is you do it twice, but the opposite. You have, in this case, to design two molds, the top and bottom mold. And you apply weight here in your composite thing. This, for the first time you do a mold, I don't recommend if you can have the vacuum bag. What I recommend is you just mill one of the molds, put it in a base, put this, place the layout here that we will talk now, and you put this inside of the vacuum bag, and you pull vacuum, and when the vacuum is like out, you close the lid, and the vacuum remains for a few hours, and then maybe in 3 or 4 hours you pull vacuum again and close again the lid. This is what I recommend, okay, for the first time, because you only need one mold. Because milling the mold is fast, but okay, say everyone is going to do this. Say this because these bags are freely available and this vacuum bag is very common you obtain. Otherwise, you have to design both. What I want you to do is do not spend any time in the design. Let's go straight away to the process, okay? Meaning, meaning don't spend a lot of time in any design something very simple like a plate, or what we are designing this time is a shell, something like a shell. So remember, have something like very simple. You don't need to do very complex. Like even if you are very simple, you could do even a cylinder, shell cylinder. I did something in my Fabacademy. I did something like this, like a parabolic hyperboloid, something like this shape. Very easy. That I use in the wall because this is flat. This line here is flat, and I use this for making a wall light. So I put this with a light, and the light comes through the burlap and up and down, and down, up in my case. So design something like this, very simple, even a sphere, a half a sphere, or if you want to test mechanical properties of shells, you can do this. How do you say? Paraboloid, hyperbolic paraboloid. It's like a crisp shape, something like this, that is very strong. And this line here is flat, and this line here underneath is flat as well. It is thinner in the middle, wider in the sides. So I want you to design something like this, very quick. And if you don't design anything today, you do half a cylinder or some short shape that you didn't even design. Okay, like a sphere, something like this. Maybe you want the sphere with some holes. I don't know, very basic design. Okay? This is what I want you to do, or this with or a mask with eyes and nose and I don't know, something, but it's very easy. It cannot be flat. Okay? Is this clear?
Yeah, got that.
Yeah. No, the design I know, but it's clear that I want everyone to do something today, to establish the design. Because otherwise, and the page, otherwise, and I want to check it, otherwise we are going to spend all the week in the design. And we don't want that this week.
Yeah.
Then, once you have the design, you have the burlap? I think yes, you have the burlap. And in the end, what happens with the resin?
Yeah, I managed to get only one bottle of that resin, which may be enough for one guy.
Hmm.
1 kg I got, 800 grams.
Frank?
Yes.
So Puneet had bought a kind of resin which is actually meant for this kind of purpose, molding and casting and making composites. Now I'm thinking about trying a different type of resins like epoxy resin, epoxy adhesives. So these are also come in two-part mixture, and per kg it will cost around 800 rupees. So it's cheaper, but it is used as adhesive. It's very strong, but it's used as adhesive.
And also the viscosity,
Yeah,
it'll have high viscosity.
it's like honey. It won't flow that easy. So these are the things I will experiment with that, as well as the super glues sort of stuff, cyanoacrylic glues. So these are the two things I'm going to try.
And
What volume does it come?
Sorry,
In what volume?
what volume?
yeah, what
Yes.
volume it comes in?
Okay,
1
so
kg.
the resin,
Mm-hmm.
both of them, the part A and part B together will be around 1.8 liters. And for that you will have to pay around 1,000 rupees, 800 rupees, something like that. Yeah, like $10 or $12. Yeah, $12.
Yeah. Also, Pradnya is sending us some materials for composite, some rice glue and some other material which is new for her also.
Okay, let's see how much volume are we going to need.
Okay.
Okay, say we will have less than that, but say we all have a piece of 30 by 30. So you know that for making a composite, you need at least two parts of fiber, at least the top and bottom, like a sandwich, and then matrix here, and matrix here, and matrix here. Okay, so say this is 1 millimeter thick, say it's a thick fiber. So we will need like another 1 millimeter here, another 1 millimeter of fiber, and another 1 millimeter here, and 1 millimeter here. Say this is at most. Say we will have 1, 2, because this will be full of fiber as well. 1, 2, 3, 4, 5 millimeters. So we will have something like a 30 by 30 by 0.5. So this is 30 by 30 is 900 by zero point 0.5 is 450 cubic centimeters. Each one you are going to need like this if you use like the full 30 by 30. Because remember, if your shape is something like this is the portion of this. Understand what I mean? But say someone will do it like this. I have another idea from all actually. You could do is you do a mold of the mountains of Kerala, Mom, Mondu, Mompundi? No, Pomundi?
One,
Pomundi.
one
Was
more.
it Pomundi?
Yeah, yeah.
Yeah. You could do also mill the mountains of Kerala in this height and apply this thing in here and have a shell of these mountains. I'll tell you how later. Now let's focus in this. So this is the maximum you need per student. So what is the volume that it was coming? in the bottle? Trivandrum? I don't hear you. Trivandrum, Puneet,
Sorry.
what is the volume?
Yeah, we got 750 grams according to the vendors.
750 grams, and in volume?
Volume, I don't know.
Mm.
Sure.
Okay, with the density, you derive the volume. So remember, this 450 is for if you use 30 by 30 and 2 layers. But remember, there is crazy people out there doing like 7 layers. I mean, you can do these 7 layers and this will be very rigid, but you don't need to go that far to appreciate the good thing about composites. With 2 layers, I think is enough, and it's the minimum, and it's enough to understand why this is more resistant to bending than one single layer. Actually, it's with 2 layers when you will get the most knowledge about this. Okay, so we are getting the difference between this and this. We are doing this. There is people who will want to do many layers, but remember that you need the same amount of matrix as more or less than the thickness of the fibers you are using. So this sandwich should be 1, 1, 1, 1, or the thickness of the
I'm sorry, like what are the materials? One is the fiber and the matrix. Is that what you're saying?
yes.
So what is the
The
difference?
fiber, the burlap or cotton, t-shirt, or whatever natural fiber you can find. Linen,
Okay.
any fiber.
Okay, those are the fiber. And then matrix is the,
It's epoxy.
oh, okay, fine. That's the box.
So this is the volume of matrix of epoxy that you need for these 2 fibers that measure 1 millimeters. If you want to do the 30 by 30 thing. If you do half, it is the half of it. If your design is, this is for a design of 900, yes, this 900 square centimeters. But if your design is 450 or 200 square centimeters, you do the proportion, or you do the calculation. This you need times the width of this, you need 100 cubic centimeter. You understand? Because of this, because of the 1, 2, 3, 4, 5 millimeters. This is the way you calculate this, but you have to calculate. You have to measure your fibers with a caliper, without not pressing, just calculating the. It's an approximate volume for knowing what you need to buy. Okay.
Okay.
Then later, apart from this, there will be like yes, it's just this. This is the volume you need. Okay. So when you have this volume, I'm gonna clear this now. You got one of the big bases here. You put the volume that you have here, and you just drop inside all the clothes that you have. Okay, and you dip all the clothes inside here, and make sure that is with wearing gloves. Very important now. You put all of this inside, so it's all fully dipped into the resin. Okay, the resin that you have already mixed with hardener and the resin itself. Okay, the hardener and the resin, and then you will put this in layers inside on top of the mold. So quickly, you have this mold. Let's say this is your mold. Okay, just a piece of cylinder. You place one layer of the food plastic, the food film. Okay, then you place one layer of the breathing material. Then you place one. It depends also in how do you want it.
Okay, the food plastic should have holes in it, right?
No, this is the breather.
Yeah, breather I understand, but the food plastic, those should
Food
have.
plastic, no, it doesn't have holes in it.
Okay.
The one that has holes in it goes on the top.
Okay.
But you can have this one without the first one without holes. Then you put the breather.
Okay.
I mean the white thing. I don't know what is the name of this.
It's a breather.
The breather, isn't it? You put the white thing on top of here. Then you put the one. Now if you want, you can put the one with holes.
Okay. Yeah.
Because you want the resin going out.
This is the.
Okay. You put the one with holes. Then you start putting your layers now. Your 2 layers or 3 layers, whatever you put. Then you put again the food film with holes, because you want the resin going out in this. Then you put again the white thing, the breather. Okay, and then you just put this whole thing inside the bag.
So Frank,
Where will the resin come?
Frank.
Yes.
So in essence, you will be having a sandwich with the fiber and stuff in the deep inside, and above that there will be the what sheet with the holes, and then the breather, then the sheet without holes, right?
Then the breather, then the film out, and on the top you don't need the film without holes.
Yeah. Okay.
In the top you don't need. So let me draw what will happen. What will happen is something like this. You will have your sandwich here. It's very thick, but it's exaggeration, with all the films, and when you pull vacuum, somewhere in here, the resin is going to go like this.
Okay.
It's going to, the excess of, this is going to be pressing in every side. I mean, the force of air, the column of air that we have on top of us, is going to press everything, and the resin is going to flow in excess. That is why we want the film, the food film, with no holes beneath everything, because the resin will go like this, and you don't want this to stick to your mold, because your mold, you are supposed to use it more times. Okay, and the resin with hole, and the film with holes, the resin can go also in that direction. Maybe you want this, or maybe you don't want this. But make sure that if you want this, like the resin is going to accumulate like this in holes. I don't like that. I don't have actually the film with holes because the resin goes outside in these directions as well if you pull vacuum. So if some of you try with the food film with holes, some of you don't. I would only use it for the bottom after the breather. So the food film with holes, the breather, and then the food film with holes. Sorry, the food film without holes, the breather, the white thing, and the food film with holes. So the resin can go also in this direction. But this is only if you have some design that the resin cannot go in this direction. Like say you have like a mountain or something like this as a mold, and you know that the resin is not going to do all this. So then you put the breather with holes so that the resin can go through these holes. Understood? Then, one very important thing. Well, we will talk about this tomorrow. Okay, now please everyone design the mold, and if you want to do the mountains, if you want to do the mountains mold, I want you to check the model of Kerala.
Frank, how are you using wax as a mold?
No, they want you to use a bigger model than this.
I know, but we got bigger wax blocks, like 30 by 30 also we got.
Yes, but it's going to be very slow because wax you cannot mill. You are going to mill foam. Look, you are going to mill foam at the maximum speed the shopbot can mill.
Yeah.
So you can make one of the 30 by 30 molds in 10 to 5 minutes. It's gonna take like some hours to mill the same mold in the modella. Because remember, you have to cut if this is the mold, you have to cut this raster layer, yeah, layer by layer until you reach the bottom, and then you need to do the finish X and the finish Y. So this in wax will be very, very slow. And this you are going to mill it with a 12 millimeters diameter tool and super fast with the ball end or the flat end, whatever you want. Okay, this is for today. Please design something. Tomorrow we are going to talk about how do you go from this design that you have made. Okay, say this is the design that you made to something flat that you can cut in the laser. Maybe it has some yeah, maybe when you make it flat it's like this. Tomorrow we are going to talk about how do you go from this 3D surface to a 2D surface that you can laser cut in the laser. Okay? Because there are some people that when they have this mold, they just put all the clothes in this, and after all, this is all full of ripples, and you have to cut it manually. mean, I prefer that you carefully laser cut this, convert this surface into a flat surface. You laser cut this, you carefully place this in the mold, and then you pull back in from it. Okay, this is what we are going to do tomorrow. But today, please, everyone, do the design. If tomorrow you don't have a design, your design is a cylinder. Understood?
Okay.
Or a cylinder, or if you want a cone, or a trunk of a cone, or something like this. But you have a design tomorrow, because we need to move forward to the process.
Okay.
And even if we don't have the epoxy, what we need to get by tomorrow is the foam.
Mm.
How are you going to do this? Is there a construction place nearby?
Yeah, there should be. There should be.
So remember, you need 30 centimeters each student. I think the plank is 120. So you have three of these per plank. Then I think the plank is 2 meters. So you have so I think it's, so I don't know, whatever it is, you calculate is how many of these squares 30 by 30 approx. It must not be 30 by 30. If it in the end it's 20 by 30, some of them, it's okay as well, you know. But calculate how many of these you have and how many students can you host this, depending of the thickness. And remembering that you have to do like a 12 thickness, something like this. Okay.
Oh,
You could do with 8 centimeters, but it's better if you have 12 centimeters. So you calculate how many of these planks you need to buy for all the students you are.
okay.
Okay. So keep me posted on this about the materials. Okay, Puneet?
I'll do that.
Okay, and for if you want to do a design for this, you go to the, I think it's NASA Jet Propulsion Laboratory. They have all DEMS. Let me DEM files. They have all Earth. They have the whole Earth in them, but there are more. This is 1 by 1 degrees. This is at 30 meters. So each pixel is 30 meters. And this is a small version. This is the whole Earth. But maybe some of you could do the whole Earth in exaggerating or a continent or a country, just exaggerating the height by 10 or 20 or 30 or 100. You know, you exaggerate the height. I mean, there are many ideas for doing this assignment today. So anything that looks like a shell is valid for this assignment. Okay? So see you tomorrow with your designs. Remember, if tomorrow you don't have design, I assign you a design. I tell you what is your design, and your design will be a cone. Is that clear?
Right, Frank. Got it.
Okay. So see you tomorrow, guys.
Bye.
Bye.
Oh,